Hi everyone, welcome back to the channel. So today in the session we are going to discuss some important terms related to semantic web. In artificial intelligence, semantic web is a very common term and we can say it is an extension of World Wide Web that we have discussed in the lecture number 68. Now we'll discuss some related terms like ontology, RDFs, OWL, Sparkwell, linked data, knowledge graphs, and inference in semantic web. So now let's just start the session. So at first, the ontology. Ontology in simple terms is like a dictionary. It is a dictionary with rules for a subject. It defines concepts, or we can say ontology defines the things and their relationships. Let's take an example first. In healthcare ontology, disease, symptoms, and treatment. We have these three things, right? AI uses it to connect knowledge logically. At first, AI systems find the disease. Based on the disease, they ask for symptoms and then the treatment, right? This is the ontology in healthcare system. Basically, in simple words, we can say ontologies help machines understand rather than just store the information, right? Next, we have is Resource Description Framework, RDF. RDF is nothing but it is simply a data model for representing information in triples. Triples here means the first is the subject, second is the predicate, third is the object, right? So RDF is a data model for representing information in triples, subject, predicate, and object. For example, we have a company, let's say ABC. It is founded by a person named XYZ. And under XYZ employee or founder, we have 1, 2, 3 named employees. So it always focuses on triples information. RDF is basically a backbone of semantic web and it helps in linking data across different sources. And AI can use RDF to answer the complex queries. Next point we have is OWL called Web Ontology Language. So, Web Ontology Language is a special language used to write the ontology. It is a language used to write ontologies. It adds more expressiveness. It is basically helps to add more expressiveness than RFDs. For example, rules like all humans are mortals. It helps AI reason about the knowledge. For example, if I say a person A is a doctor, so OWL can help deduce A is also a human. If I say A is an actor, then OWL helps us to deduce it as A is also a female. Clear? It is widely used in research and knowledge systems in AI. Next we have is Sparkle, that is query language for RDF. As its name implies, it is nothing but it is SQL, structured query language for semantic web data. It is used to search RFD databases. For example, Sparkle query can find all universities in India established after 1950. Right? This is an example. If I write Sparkle query to find all universities in India established after 1950, it allows AI to fetch very specific linked data, important tools for researchers and developers. Next we have is linked data. Linked data means connecting related information across the web. It uses RDF and URLs to link knowledge globally. For example, Wikipedia. Wikipedia links facts with other open data sources, and it helps build a web of data instead of just a web of document. This makes AI systems much smarter in searching and reasoning. So, in simple terms, it can be asked in the examination which of the following semantic web related terms helps us in searching and reasoning in a better way or in a smarter way. The correct answer will be your linked data. Another is knowledge graph. So, a knowledge graph stores information in the form of nodes. Nodes are called the concepts, and edges. Edges are called here relationships. Google Knowledge Graph is a famous example. Instead of just showing links, it shows some facts and it also shows some connections. For example, knowledge graphs are widely used in AI, search engines, and chatbots. We have so many search engines that we are using these days, right? So, these are the examples of knowledge graph. We have already discussed about it in the previous session, right? Next is, other than this, we can say it is used in open data projects. It is used in open data projects, government portals, and by Google and Facebook for better recommendations. Next is inference in semantic web. Basically, it is a network of facts where entity means nodes, are connected to the edges. These are called the relationships. Why is knowledge, why is inference in semantic web is important? Basically, inference is the ability of a machine. Inference is what? It is the ability of a machine to derive new facts from existing data. Why is this important? So machines can think beyond the stored facts. Examples can be examples can be, let's say we have one fact that cats are the animals and animals need food. And other than fact, we have inference. Inference can be cats need food. I'm repeating the example. The fact is cats are animals and animals need food. So the inference can be cats need food, right? So these are basically used in expert systems, reasoning engines, and recommendation systems. So inference engines are used there. Next we have a semantic search. So search that understand the meaning of query, that understands the meaning of query, not just the keyword. Why is semantic search important? Because it gives more accurate results. And semantic searches are used in search engines like Google, like Bing, like AI powered search tools. So, all these are some important related topics of a semantic web. I hope students every concept is clear. If you have any doubt left, you can surely share in the comment section. I will definitely help you out. So thank you so much everyone, and if you want me to continue the series, then share your feedback. Thank you.